All right, 9.2. So we will use normal distribution tables if sigma is known, standard deviation of the population. Population standard deviation, SD for standard deviation, is known. Okay, sigma. Or population is normally distributed. Here's our steps. Okay, step 1, we're going to state the null and the alternative hypothesis. Step 2, we're going to select if it's a Z or a T distribution, so that is going to depend on the standard deviation. So Z, population standard deviation. T, that is sample standard deviation. And then proportions are Z. Okay, then, based on the significance level, so you'll be given a significance level of the test, you'll find the rejection region, which is what we did 9.1. Step 4, you're going to calculate the test statistic of Z or T using the sample data. Then we'll use that to find the p-value. The null hypothesis is rejected if the p-value is very small, such as 0.05 or less. Okay, and then here's a memory tool. If the p is low, the null must go. If p is high, the null will fly. Again, I like to draw it out, so usually I can see whether it's going to work or not. All right, and then you make a decision, so it's either reject or fail to reject. 2 decisions, yes or no, okay? If critical Z or T falls in the rejection region, you'll reject the null. We also use p-values to make a decision about the null. If the p-value is less than the alpha value, you will reject the null. Again, it will fall in that rejection region. Very important, we're testing the null hypothesis. Okay, we reject or fail to reject. We're not testing the alternative hypothesis. If we reject the null, it is likely there is some difference, and perhaps the alternative hypothesis is correct. We are not proving the alternative hypothesis. We're simply stating it's more likely to be correct than the null. That's why we say fail to reject the null. We don't actually say anything about the alternative hypothesis. Okay, so let's do an example. According to CBS News, college students spend an average of $158 on course materials per course. However, a college affordability committee suspects the average cost of course materials has actually increased since 2018. A random sample of 100 college graduates found that students spend an average of $167 on course materials per course. Assume the distribution of all such course materials costs is normally distributed with a standard deviation of $40. Using a significance level of 5%, do the sample data provide enough evidence to support the claim that the average cost of course materials has increased since 2018? Okay, so what we are given here, first of all, let's go ahead and write that down. So we have we have an average of $158 per course material. Let's see. They suspect it's actually increased. A random sample of 100, so sample of 100, found that the average in the sample is 167. Let's see. Assume this is normally distributed with a standard deviation of 40. Significance level of 5%. There we go. So let's write that out. So we have a population mean of 158. We're given a sample size of 100. We are given a sample mean of 167. We're given a standard deviation for a population of 40, because it says assume that all course materials are normally distributed with a standard deviation of 40. And then our significance level, that's alpha, 0.05. Okay, so like I said, when you're looking at this, look at the last question. That's going to give you the alternative hypothesis. So the last question is, do these sample data provide enough evidence to support the claim the average cost of course materials has increased since 2018? So the alternative hypothesis is going to be that the mean is actually greater than this 158. Okay, so that last sentence gives you that alternative hypothesis. And then the null is just the opposite of that. So the opposite of that is that the mean is less or equal to 158. Okay, now the critical value of the test statistic is going to be that z-value that we just calculated. So what this is a significance level of 0.05. And if I'm looking at my test, okay, the test is always going to be based off of where the alternative is. So the alternative is going greater than, which is pointing to the right. So this is a right-tailed test. That is alpha. So it's like an A, it's a Greek lowercase a. So if I drew that and then just put another tail at the top of it, so you can kind of just like draw down and up like that. Okay, so it's right tail test, 0.05. So we're going to have 0.05 over here. When we did the significance levels in 9.1, we had a left-tailed with it, but what we would do here is, since this is 0.05, this is going to be 0.95. So we would go inverse norm, because it's a z-value, and then 0.95, 0, and 1. And that would give us, that would be our critical value. Okay, so that gives you positive 1.645. Okay, so here's my 1.645. My rejection region is in the right tail. So this is my rejection region. This is my OK region. So my decision, my rule here is that I am going to reject the null if I get a z-value greater than 1.645. Okay, now this 1.645, because you're going to be asked, you know, probably 4 or 5 questions for each paragraph. So the first question is, what's the null and alternative? Second question, critical value. So the z-value that would cause the rejection, that's called your critical value. Okay, now the actual z-value of this data, that's called the test statistic. So you want to find the test statistic. Now you're still using the same calculations from chapter 7. Okay, so the test statistic is going to be, you're going to first find the standard deviation of x bar, which is the standard deviation of the population over the square root of the sample. And then you're going to find the z-value, which is going to be x bar minus the mean over the standard deviation of x bar. So those are the two formulas you're going to be using. So we're going to go ahead and do that. So actually, let me Put this one over here. Do this. Okay, so let's find the standard deviation of x bar. So the standard deviation of the population we wrote down was 40. And the sample size is 100. So 40 over the square root of 100 should just be 4. 40 over 10. And then the z value is going to be x bar, which is 167, minus the mean, which was 158, over 4. So that is going to be, I think, 9 over 4. So 2.25. Okay, that is your test statistic. Okay, so that would be another question. And then the last part, what is the result? Well, if I plot this on the normal curve, it's like right here. So it's in the rejection region. Okay, so here we say, well, 2.25 is greater than 1.645. It is in the rejection region. So we say reject the null. Okay, here's how you do the p-value approach. Okay, so that was using the critical value. I like it because you can clearly see where that z-value lies. This one, you would find that you do all of this anyway. Okay, you have your significance level is 0.05. Okay, you need to find p, so you need to find the probability for 2.25. Okay, so that would mean find probability, chapter 6, which means you would do normal CDF, 2.25, 99. Okay, when you do the probability, you're going to do it on whichever side of 0 it is. So if it's on the right side of 0, then it would be positive 99. If it's on the left side of 0, you would use negative 99. This would give us a probability value of 0.0122. And then you compare that to alpha, so you have 0.0122. That's p. And then alpha, 0.05. This is less than, so what is it? If p is low, the null must go. Reject the null. So p is less than alpha, reject. Okay, but you will have a couple questions that will ask you what that p-value is. So you just take that next step and you do the normal CDF and you go through the test. Okay, let's do another example. All right, AT&T claims that subscribers to their Internet 500 fiber optic internet service experience download speeds of at least 500 megabits per second. At least 500 megabits per second, so that's going to be that null, but we'll get to that. However, many subscribers have complained their average download speed is actually lower. A random sample of 75 AT&T subscribers found the average download speed was 492 megabits per second. Assume that download speeds of all such subscribers is normally distributed with a standard deviation of 25. Use a significance level of 1%. Do the sample data provide enough evidence to substantiate the claim the average download speed is less than 500? Okay. What we got here? So we have download speeds of at least 500 megabits per second. That's going to be the mean. The sample size, 75. They found the average of the sample was 492. Okay, all subscribers is normally distributed with a standard deviation, 25. So population standard deviation, significance level of 1%. All right, so we have a mean 500. We have a sample size of 75. We have a mean of our sample, 492. We have a population standard deviation, 25, and a alpha, 0.01. Okay, the question at the end, is there enough evidence to substantiate the claim that the download speed is less than 500? That's the alternative. So the alternative is that the mean is less than 500, which means the null is that the mean is greater than or equal to 500. Critical value, you have a significance level of 1%, so 0.01. The alternative is pointing to the left, so this is left tail. Okay, so here we go. This is 0.01. We're going to go inverse norm. 0.01, 0, and 1. And that'll give us negative 2.326. Okay, so we'll put that right here. And then we'll draw our model. So here I am rejecting right here anything less than negative 3.2326. And then we're good above that. So we'll reject if we get a z-value less than negative 2.326. Okay, we will calculate the test statistic. So first we need the standard deviation of x bar. So that will be our standard deviation of our population, which is 25 over the square root of 75. That will give us 2.8868. And then we'll do our z-value. So that'll be x bar 492 minus 500 over 2.8868. Let's see, 492 minus 500 divided by 2.8868. So negative 2.7712. All right, so that is our test statistic. And that's going to be roughly like right there. So that is in the rejection region. So here we say negative 2.7712 is less than negative 2.326. So we will reject the null. the p-value, because it did say p-value approach, so it will want that exact p-value. It's on the left side, so you're going to go negative 99 with an upper limit of the negative 2. So normal CDF. Lower limit negative 99, upper limit negative 2.7712. Okay, because it's on that left side. And that'll give you 0.00200028. Okay, so that would be your p-value. And there you compare that to alpha. So you have 0.0028 and 0.01. It's less than 0.01. P is less than alpha. So you reject the null. All right, how are we doing? This can be confusing, but if you just take it one step at a time, it makes it a little bit better. Okay, last example for here, and then we'll take a break to get to 9.3. All right, the athletic director would like to know if the athletes at IRSC academically perform similar to that of all IRSC students. The mean GPA of all IRSC students is 3.15 with a standard deviation of 2.2. A random sample of 50 athletes produced a mean GPA of 3.2. Do the sample data indicate that IRSC athletes academically perform differently than the rest of IRSC students? Solve using p-value and a significance level of 2%. Okay, so what we have here, let's see. The mean GPA, so the mean of all, 3.15 with a standard deviation 0.2. Sample is 50. That produced a mean of 3.2. Significance level is 2%. So let's write that down. All right, so we have population mean 3.15. We have a population standard deviation 0.20. We have a sample size of 50, sample mean 3.2, and an alpha level 0.02. All right. The null and the alternative. So it says here, do the sample data indicate IRSC athletes academically perform differently? So differently, what is that going to be when we say what the mean is? If we're in terms of those three options. You had less than, greater than, or not equal. It's different. It's not less than or greater than. So this would be not equal. So the alternative hypothesis is that the mean is not equal to 3.15. The null is that the mean is equal to 3.15. They don't want to know if they perform better. If it were, do they perform better, then that would be that the alternative is greater. Okay, they just want to know if they perform differently. So you have to look at that wording there. So now this means this is a two-tailed test. Okay, so with a significance level, two-tail, significance level is 0.02, you're going to have to divide that by 2. So 0.01 on either side. Okay, so if we do inverse norm, 0.01, 0, and 1, that'll give us the negative value, and then the positive value is going to be the same. So that gives us a negative 2.326. So negative 2.326 and positive 2.326. Okay, then our rejection region to the left of negative 2.326 and to the right of positive 2.326. And if we're in between, then we're okay. Okay, so we will reject the null if z is less than negative 2.326 or greater than positive 2.326. Okay, so let's calculate. We're going to start with the standard deviation of x bar. So that'll be the standard deviation of the population, 0.20, over the square root of the sample size, 50. Okay, so that gives us 0.0283. Okay, then we'll find the z value. So that'll be x bar 3.20 minus the mean 3.15 over 0.0283. So 2 minus 3.15 divided by 0.0283. So that gives us 1.7668. Okay, that's going to be our test statistic. Okay, if we look at that, that is right there. So that's in that non-rejection region. Okay, so we're good to go there. Okay, so 1.7668 is less than 2.326, and it is greater than which means here, so what we would say here is fail to reject the null. Okay, which means that, okay, the null hypothesis is that the mean is equal to 3.15, so it's likely that the mean of athletes is also equal or close to equal to 3.15. That student athletes are not different based on this sample of 50 athletes. Okay, we do want the p-value for this, so just here we would just do, so the 1.7668 is to the right of 0. So for the p-value, we would go normal CDF, and we would want to go to the right. So we would go 1.7668 and then positive 99. And then that'll be 0.0386. Or we could say, yeah, 0.04. But that is going to be greater than your alpha, 0.02. So you fail to reject. Okay, so we will stop there for 9.2.